So here I am doing some playing around with a couple points. So I chose 3 points specifically in three-dimensional space. I just kind of picked some random numbers. And then I got a mean squared error point. And then I got a mean cubed error, but it's not just cubed, it's also absolute valued, so that you kind of are working with distances. I think that would be smarter. Now, I have to make sure that I include the origin here because that's sort of what I'm thinking about here, what I'm reasoning about. Now, remember, in 2 dimensions, you're going to have this point to represent what these might be representing if they're just kind of picked randomly on a normal distribution, to guess what the actual real data actually is. And the thing is, because the whole Stein's paradox thing where they use shrinkage to pull this towards the origin to sort of get a better representation of a point that represents, when you're using the minimum squared error, it's like it becomes biased, but then it becomes more accurate in the square. See, that's an important note. It's not just any error. It's there's a squared error, which people like to think, that represents error, that represents distance, but not necessarily. Because if you're in 3 dimensions, if you're going to think about distance in 2 dimensions, you would use sort of the Pythagorean theorem. But if you're thinking about distance in 1 dimension, well, if you really think about it, you could just take sort of the average between 2 points, or you don't have to necessarily square things in order to see. I feel like Stein's paradox might be, my intuition tells me that it might be built out of confusion, and it's like a bias that statisticians might have, sort of similar to these other paradoxes and things that I've been talking about, like, for example, the whole problem of picking a door out of the 3 doors problem. We know about how that actually has a bunch of assumptions. So some people pointed out the math, but then they don't point out that their assumptions are a little strange. It's the same thing with voting. People will say, oh, we can't have democracy, and then they'll point out Arrow's theorem, but that they don't realize that Arrow's theorem axioms are kind of actually nonsensical. So here we have something that we're treating as a sensible distance for some reason in higher dimensions. But if we're going to pick a point that represents these other points, well, if it's in 3 dimensions, we might as well use a cubed system instead of squared system. And you might think, well, that's different. It punishes the more distant objects more. But think about it. Let's just look at this for a second. I only picked one initial set of 3 points, but notice how the blue point actually seems like it's kind of shifted a little bit to the side and kind of towards the origin from the cubed point. And that might be an interesting thing to point out with this, because to minimize your squared error, remember they said that you'd want to bias it towards the origin. But here, we don't want the origin to give us a bias in the first place, right? Because these points could exist anywhere, regardless of where the origin actually is. And intuitively, you wouldn't want the origin to sort of skew where these points would be, because ideally what these points actually represent are their own normal distributions around these points. And they're not skewed towards any origin either. They're actually just centered normal distributions around these points. So what is actually going on here? Should we, when we're actually modeling 3 independent variables and we're trying to figure out how to represent them with an estimate, should we be doing this? Should we be using a cubed distance instead of a squared distance? And what kind of implications does this have on our assumptions about physics and maybe neural network models and all sorts of other things? Like maybe neural network models should be using different types of distance. You know, maybe they could be a lot more intelligent and solve problems a lot better. I mean, we have chatbots that are trained on spoken languages, and before the chatbots even existed, I wanted to just train one on raw lambda calculus deductions to make a more efficient reduction. And that would be a generalized computing algorithm. I mean, that would be just pure intelligence. You don't want biases, right? That's how they made AlphaGo initially, back when in the chess days. Or sorry, after chess was mastered, then they mastered Go. What did they do? They made the computer, they didn't train it on any existing strategies, and they just trained it straight, unbiased, on raw playing the game from scratch against itself, right? So that's what we want. That's what really you want to do if you want to have a really accurate chatbot that can do really precise, really accurate, correct math and always be absolutely flawless in its reasoning and its logic, instead of extremely, where we're at is just like really bad. You'd want to train it on just a whole bunch of true statements and no garbage, and you'd want to raw, train it, give it really hard problems, but no foundational strategy, because the whole point is it's making up a new strategy that's a higher level strategy to think. It's a higher order strategy. That's the whole point. So let me plot a few more of these. And I'm going to double check and make sure that for the most part, the blue one is maybe closer to the origin. I'm assuming that the blue one isn't necessarily closer to the origin, but it's closer. It's going to be further away from the outliers, right? So if the outlier was close to the origin, but then the group was over here, maybe the red one would be closer. You know what I mean? So I don't know really how to think of it, but I feel like there's some sort of implicit bias involved with the definition of a distance, because if you have to use a shrinkage, well, you guys can watch the video. There's a good video from 2 years ago about the Stein's paradox. I don't know if I like the number file video as much as that one. That one was actually really good, or it might have been 4 years ago, but it's a really good video, really in depth, and they do a lot of 3D plotting and stuff. So I'm gonna check a few more examples, and I want to just see maybe there's something to this.